Okay, this is the 6.1 and 6.2 notes, page 5. We're going to go through these fairly quick, and then on page 6 we will talk about transformations of exponential functions. Looks a little different because it's not quite as obvious sometimes as when we're transforming a parabola. So let us take a look at a growth function, and we know this is a growth function because our base, which is 2, is bigger than 1. So whatever we're multiplying by, each step of the way, it's going to increase the value because it's bigger than 1. So I'm going to just plug in -2, -1, 0, 1, 2, 3, sure. Right. 2 to the -2, 1 over 2 squared gives us a 1/4 here. 2 to the -1 becomes 1 over 2 to the first, which is 1/2. 2 to the 0, anything raised to the 0 power is 1. And then probably more comfortable with these down here. 2 to the first is 2. 2 to the second is 4. 2 to the 3 is 8. Keep in mind, we can plug in anything we want. So our domain is going to be -infinity to infinity. We know this is bounded by the x-axis. I cannot raise something to a power and get a negative answer. So our range is 0 to infinity. We cannot use 0. Because it does not cross the x-axis, there are no x-intercepts. And we know our y-intercept is at the point 0, 1. Our horizontal asymptote, I'm going to leave those there for a minute and graph this. So 0, I'm going to go ahead and label these. We got, which makes it a little crowded over here on the negative side, but we're going to be okay. I have got 1/4, 1/2, 1, 2, 4, and 8. I get this exponential curve that I know is approaching the x-axis. Sorry, this looks like it's bouncing up. It's not supposed to do that. Okay, so our horizontal asymptote, it'd be too fat to draw an asymptote, is our x-axis. And if you think about it, I got the point 1, 0, 2, 0, 3, 0. That's where y equals 0. We have no vertical asymptote. Our end behavior, what happens at the ends? So as x gets larger, as x goes to infinity, our y also goes to infinity. That's what's happening here. And as x goes to -infinity, our y is approaching 0, right? It's not going to cross the x-axis, but it's going to continue to get closer and closer to 0. Now, just for comparison, I want to graph in, we're going to call it g of x, 3 to the x, and see what happens as the base gets bigger. 3 to the 0 is still 1. So all of our exponentials are going to intersect at that point 0, 1. At 1, when x equals 1, y equals 3. When x equals 2, y equals 9. So on the positive side of the y-axis, the bigger base is going to make our graph rise faster. Over here on the negative side, to the negative 1, there's 1/3, 1/9. So it's actually going to be below the other graph to the left of the y-axis and above my other graph to the right. So let's take a look at what happens when we have a decay function. And I am going to see if I can make this fairly consistent with what I had before. 1/2 squared, I'm going to start at the bottom, is 1/4. 1/2 to the first is 1/2. 1/2 to the 0 is 1. 1/2 to the negative 1 means we take the reciprocal, 2 over 1, raise that to the 1. I get 2, 4, and 8 here. Okay, this is still an exponential function. The domain is still -infinity to infinity. The range is still 0 to infinity. I still have no x-intercepts because it does not cross that x-axis. And my y-intercept is the point 0, 1. So let's go ahead and graph this. One, two. We got -3, 8. That would be 9. I got -2, 4. -1, 2. 0, 1. 1, 1/2. 2, 1/4. And I get the graph that looks like this. Notice this is a reflection over the y-axis, right? That's what happens when we make x negative, which is basically what we're doing when we take a look at the graph of the reciprocal. Okay. So our horizontal asymptote, same place, y equals 0. We have no vertical asymptotes. Our end behavior swaps. So as x approaches infinity here, our y, our f of x, approaches 0. And as x approaches -infinity, our y approaches +infinity.